In the previous video, we discussed about the need for serverless inference. If you haven't watched the video yet, it's there in the first link in the description. Do watch it before starting this video. In this video, we are going to discuss about the data preparation. So the first step of the pipeline is to build this Cockroach TTS inference. For that, we are going to use a standalone script. This is a very simple script where the objective is to take in a text as an input and produce speech as an output. Let's go through the script. We are going to initialize this Cockroach pipeline, and we are going to write a small utility which takes in the text. So this is the text which user is going to pass in, and what type of voice that we have. Cockroach supports a couple of different voices which you can pass in. So we are going to default it to AFR. And once we get this text, we are going to pass it to the generator and generate the audio. And once we have the audio, we are going to concatenate everything using NumPy and return the final audio. When we invoke this particular method with the input text from the user, then it returns the audio, and we are going to use the sound file library to output this particular audio in the wave format. Let's go ahead and run this and check it out how it works. So I'm going to invoke Python utils and standalone inference.py. Let me run it. Now we'll see it has loaded this Cockroach 82 million parameter model in CPU, and then it has converted the text into the audio format, and then audio is saved as output.wave. And then here we have the output.wave, right? So this is the output. We have this standalone step ready, which is nothing but the step of Cockroach TTS inference. It works well in the local computer, but in order to serve this as a model, we need an API layer. We are moving to the second layer, which is the FastAPI microservice layer. So the objective of this particular layer will be to consume text and a couple of other parameters from the client, and then pass in this input to the Cockroach TTS inference pipeline and produce the audio. Once the audio is produced here, consume the audio and return it back to the client. So to do that, I already have created this app folder, and inside api.py, we have the implementation. Let's quickly look into this implementation. So we have initialize this pipeline globally. We don't want to load the model over and over whenever we get a request. So it's initialized globally once. And then here we have the method which takes in the text and produce the output. And then here we have the FastAPI app with a couple of parameters. User can pass in the text, which the user wants to convert, customize different voices. By default, it is AF hard. And user can control the speed as well. This is going to be the async method, which is going to perform the text to speech. So is going to take in all these three different parameters and then pass in the parameters to the method and then generate the audio. So here we have the audio as an output. Once we have the audio, write it to the buffer using sound file and then return the audio in the wave format, right? So this is the async implementation so that we can run this as a API service and pass in multiple different requests at the same time and asynchronously process it, right? And then another important point to note here is that we have one another async method. And it is mandatory to have this method if you are going to serve it using runpod, right? So we are going to deploy this application in runpod on a CPU-based inference, right? So once you have this as a serverless service in runpod, runpod is going to invoke this health check method once in few seconds and check the health of the application. This method we can use it as a test. So once we have the app up and running, can invoke this method. If we are getting this JSON response, that means that we are able to successfully communicate to the app. So let's go ahead and run this particular app. To do that, let's go ahead to the same terminal and Python, and here we have app slash we have api.py, right? So let's run this and wait for the FastAPI layer to load. Okay, now it has loaded the model and it has loaded the service. Now we can see that our backend service is ready, right? So let's go ahead and pass in a request and test it out. To test this FastAPI service, I have created a simple grad.io web UI. So let's go ahead and run this Python utils and then grad.io web UI. Let's run this. Let's wait for the service to start. Okay, the UI is running in my local machine 7860. So let's go here, localhost colon 7860, right? Now let's launch this UI. Okay, here we have the input text which we can pass in, and here we can select a couple of different voices that we want, right? And here you can control the speed in the slider, right? If you want it to be slow or if you want it to be like faster, right? And here we can type in the text. So what this code is going to do is when we invoke this method, it is going to talk to localhost 80 where our service is running, and then invoke the API URL audio speech by passing in all the information that we send it from UI. Okay. So here I have a custom method where I get the payload and then do a post request call to the FastAPI service, and then get the response, which is the audio, and then return back to the UI, right? So let's type in some message. This is a sample message. Now we have the message here, and let's hit the generate audio, right? Now we can see that it is processing, and let's wait for a few seconds to see. Yes, now within 6 or 7 seconds, we are able to generate the audio. Here we have the audio where
This
we can
is a
play.
sample message.
But let's go ahead and confirm this by moving into the log section. And here in the fast API, we can see that we received a request in the post, and then the response was 200. Okay, that means that it has converted that to audio and responded it back to the user interface, right? Now we have the local setup ready. The next step is to serve this application in run pod serverless. For that, in order to put this, entire setup, we are going to use Docker. I have already created a Docker file here. In this particular Docker file, we are going to use the base images 3.10, the Python Slim image, and then install the basic libraries. And then we are going to use the torch. For this particular deployment, I'm going to deploy this in Runpod serverless in CPU version, right? So that's why I have installed the CPU version of the torch, and then install what are the dependent libraries. You have Kokoro, and then you have FastAPI. We are going to do multi-part upload, and we have Unicon, right? And then we are going to copy this app. This is the application that we have created, the FastAPI app, to slash app, and then we are going to run this in port 80. Once this Docker build is successful, we are going to start the service using this particular command, and we are going to run it in 0.0.0.0 and port 80, right? So this is the basic Docker file, and to build this, you can go to the terminal and then use the typical Docker build command, docker build -t, and here goes your username and the whatever the name that you want to keep for this particular image, and then the version, and then space dot, right? It will build the Docker, and you use Docker push to push in this image to your Docker Hub. I've already created this Docker setup and pushed it to my Docker Hub account. Now this particular Docker is available in public. You can even have it as a private Docker, and it is ready for serving using serverless inference. The next step would be to deploy this Docker image and create multiple workers in Runpod and servers and run the inference with Runpod serverless. See you soon in the next video.